differential equations. Let us discuss about the methods of solving the first order, first degree differential equations. But before that, we will try to identify the types of differential equations so that this will be helpful for us to adopt the suitable method. We have three types of the first order, first degree differential equations. Differential equation with variables separable. When you say variables, x and y are variables and they can be separated into LHS and RHS. So variables separable means they can be separated. And the variables inseparable means they are fully homogeneous, and we have to adopt a different technique for that. In between that, this is actually variable separable, but we have to make it as a variable separable in such a way it should be reduced. So the solving first order, first degree differential equations can be of three types. One is differential equation with variables separable. Second, this differential equation reducible to variable separable type. Third one is homogeneous, where the variables are closely associated, so we have to adopt a different strategy for that. Let us discuss one by one. Differential equation with variable separable means, let me consider the dy by dx. That is the first order differentiation. That is equal to f of x and g of y. It means that is a function of x and function of y. So since they are two different functions, they are represented by f and g. So we can have this type of equation, differential equation, where they can be easily separated. For example, dy, so the g of y can be brought to the LHS and dx can be brought to RHS like this. Now in this case, the variables are easily separated, then we can proceed with the integration. So this is one type. Second type is differential equation reducible to variable separable form. Now let me explain this with an example. Let us consider x plus y minus 3 of dy by dx is equal to 5. Now we can replace this x plus y minus 3 by z. So we can substitute this x plus y minus 3 by z. That is, we are bringing a third variable and thereby we will try to break into two variables, that is isolate into two variables. Now x plus y minus 3 is equal to z. Now what we are doing here is we have to differentiate this with respect to x. So when we differentiate this equation with respect to x, you know differentiation of x with respect to x is 1. And what about y? That is dy by dx, because it is differentiated with respect to x. And for constant this is 0, therefore dz by dx. So now we have got 1 plus dy by dx is equal to dz by dx. Is it okay? Right. Now we can take this dy by dx and by taking 1 on the other side. So dy by dx is equal to dz by dx. This plus 1 becomes minus 1. And now what you can do is, you have got dy by dx, is it not? You can substitute this dy by dx here, okay? As well, instead of x plus y minus 3, you can write z. Are you able to follow? So I am replacing this x plus y minus 3 by z, okay? And replacing this dy by dx by this dz divided by dx minus 1, okay? Then I have left the phi intact. Now I can put z, you can do one thing, that is z into dz by dx. I have split this, and minus z, that becomes plus z, so z plus 5. Now dz divided by dx, you can bring this z to the RHS, so z plus 5 divided by z, right? Now our idea is to bring the dx, so you can bring this dx to the right hand side. So we have dx here. Now we have totally isolated z and x, but note that point, still we have not yet isolated the y, okay, because z is x plus y minus 3. However, by taking the third variable and substituting, now the first variable and third variables are totally isolated. Is it clear now? Right. Next. Now we have z plus 5. So we'll do one thing. Here we have got z plus 5 and this is z and dz. So integral of this one and dx. Now what we can do in order to integrate this, okay, we can do one thing, add 5 and subtract 5, okay. That is, add 5 means 5 minus 5 is 0, so you can add 0. Instead of 0 you can put add 5 and subtract 5, so 5 minus 5, that is 0. So the term is intact, I have not at all disturbed. But in order to make this, as we can separate this into two equations, two fractions. So z plus 5 divided by z plus 5, and I have put minus 5 divided by z plus 5. Is it clear? So this can be struck and made as 1. Therefore 1 minus 5 divided by z plus 5 of dz. Now we can split this into two integrals. So 1 of ds, so integral dz, and what about this one, minus 5 divided by z plus 5 of dz, and we have got already dx. Now integrate everything. Dz becomes z, and what about minus 5, that is constant, you can take outside the bracket. So 1 by z plus 5, so that is nothing but log of modulus of z plus 5, right? And on the other side you have got dx, so integration of dx is equal to x, so x plus c. Now we have to substitute this z value by x plus y minus 3. So we have substitute x plus y minus 3 and 5 into log of, instead of z you can put x plus y minus 3 plus 2 plus 5. So 3 minus 3 plus 5 becomes a plus 2, and you got x plus c. So x plus y minus 3 and all these things. Now what you can do, you can bring the x on the other side, is it not? Thereby you can eliminate these two x, got it? And here you have got minus 3, so it becomes plus 3, so c plus 3. So c plus 3 is another constant, so you can put distinguish by put c dash or c1. Now the remaining is y minus 5 log of x plus y 2, that is log of modulus of x plus y plus 2 is equal to c1. So this is the solution for the differential equation. Okay, are you able to understand this?